You lived a complete life before you reached 3 years of age. You were born into the world. You opened your eyes to see for the very first time. You heard the sound of your mother's voice. You experienced the taste of food. You took your very first steps. You spoke your first word. Yet, you do not remember any of these events. Not a single moment remains in your memory. Most people assume the explanation for this is simple. They believe your brain was not ready yet. You were simply too young. But that explanation is not correct. The real answer is actually far stranger than you would expect. Your infant brain was not failing to record your life. It was recording everything that happened. Your memories were successfully created, but something came along and destroyed them. In 1905, Sigmund Freud became the first person to give a name to this phenomenon. He called it infantile amnesia. We know for a fact that babies can form memories. In the 1980s, a psychologist named Carolyn Rovi Collier at Rutgers University conducted an elegant experiment. She attached a ribbon from the ankle of an infant to a mobile that was suspended above their crib. The infants quickly learned that kicking their leg caused the mobile to move, and they thoroughly enjoyed it. When she brought the same babies back to the lab days later, they remembered the connection. They started kicking their legs immediately. Even 2-month-old infants could hold that memory for a couple of days. 6-month-old infants remembered it for weeks. So infant brains are capable of learning. They can store information. They can recall it later. But those early memories do not last. By the time you reach adulthood, every trace of them is gone. For decades, scientists could not fully explain why this happens. The first part of the explanation is structural. The hippocampus, which is a small and curved structure situated deep inside your brain, serves as the engine of memory formation. This structure is what enables you to take a real-life experience, like a birthday celebration, a conversation, or a walk in the rain, and encode it as an episode that you can later replay in your mind. In the adult brain, the hippocampus collaborates with the prefrontal cortex to label, store, and retrieve these episodes. But in infants, this system is highly underdeveloped. The connections between the hippocampus and the cortex are still being constructed. Crucial regions, such as the dentate gyrus, which serves as a gateway for new memories, are not fully wired until somewhere between the ages of 2 and 4. Consequently, your infant brain was capable of forming short-term memories, but it simply could not transfer them into long-term storage the way an adult brain does. But that represents only half of the story. And what comes next is actually even stranger. In 2014, a pair of neuroscientists in Toronto made a discovery that completely transformed our understanding of infant memory. Sheena Jocelyn and Paul Franklin, working at the hospital for sick children, proposed a hypothesis that sounded almost absurd. They questioned whether the exact process that constructs your brain is also the very thing that destroys your memories. This is what they meant by that statement. During the first years of life, your hippocampus generates new neurons at an extraordinary rate, a process known as neurogenesis that is absolutely essential. These new brain cells are responsible for wiring the neural circuits you will rely on for the rest of your life. However, Jocelyn and Franklin suspected that this growth came with a cost. Each time a new neuron integrates into an existing circuit, it disrupts the connections that were already established, which were the very connections holding your memories. To test this hypothesis, they conducted experiments on mice. When they artificially boosted neurogenesis in adult mice, those animals began to forget things they had previously learned. Conversely, when they slowed down neurogenesis in infant mice, those young mice retained their memories for a longer period than normal. The findings, which were published in the journal Science, pointed to a highly counterintuitive conclusion. Your infant brain was not too weak to retain memories, but was instead too busy growing. The same massive generation of new neurons that constructed your brain also overwrote the memories stored within it. Your earliest experiences were not lost because they failed to save, but because your brain kept constructing new rooms and tearing down the old walls during the process. However, there is another layer to this phenomenon, and it may be the most unusual part of all. To form what scientists call autobiographical memory, which is the type of memory where you are the main character of an experience you can replay in your mind, you require something most people take for granted. You must possess a sense of self. You need to understand that you exist as a person who is separate from the world around you, and that things are happening directly to you. In the late 1990s, developmental psychologists Mark Howe and Mary Courage argued that this self-awareness is the critical missing piece. Prior to roughly 18 to 24 months of age, infants do not recognize themselves as distinct individuals. The classic test for this is simple, involving putting a dot of rouge on a baby's nose and placing them in front of a mirror. Before 18 months, babies treat the reflection as if it were another child, and they do not reach for the mark on their own face. After 18 months, they do reach for it, recognizing that the person in the mirror is themselves. This moment, representing the birth of self-recognition, closely tracks the earliest age at which autobiographical memories can form. In other words, you cannot remember being a baby, partly because there was no you yet, at least not in the way you experience yourself today. There was no internal narrator inside your head packaging experiences into a story that belonged to a person called you. This raises a rather uncomfortable question. If you lacked a continuous sense of self, and the brain that held your earliest experiences physically rewired itself beyond recognition, is the baby in your old photos actually you? Or is it someone else entirely? Is it someone who lived in the same body, but whose mind was literally disassembled and rebuilt, neuron by neuron, into the person you eventually became? There is one more piece to this puzzle, which is language. Developmental psychologist Catherine Nelson spent years studying the way children form lasting memories. Her conclusion was that language does not simply describe our memories, but actually structures them. Before you could speak, your experiences were encoded as raw sensory impressions, consisting of sounds, textures, emotions, and light. But without words to organize them, those impressions had no framework to attach to. Once children begin speaking, and especially once they begin having conversations with adults about past events, such as remembering a trip to the park, their ability to form lasting memories improves dramatically. Language gives memory a skeleton, and without it, experiences are like water with no container, existing in the moment and then disappearing. And this is not just a theory. Psychologist Chi Wang at Cornell found that the age of your earliest memory actually varies depending on your culture. In Western cultures, where parents frequently narrate their children's experiences by asking questions, telling stories, and building personal narratives, earliest memories tend to start around age 3.5. Among the Maori of New Zealand, whose oral tradition places extraordinary emphasis on personal history and storytelling, average first memories reach all the way back to age 2.5. In some East Asian cultures, where early childhood narratives focus less on the individual, first memories tend to start closer to age 4 or later. The culture you grow up in literally shapes how far back your memory reaches. So here is what actually happened to your earliest years. Your hippocampus was not ready to build long-term memories. And even when it started to, the flood of new neurons tore through the circuits that held them. You had no concept of self to anchor experiences to. And you had no language to give those experiences a structure that could survive. It was not one thing, but everything all at once. Every human being who has ever lived went through this. Every person you have ever met has a black hole where the first years of their life should be. And the answer to why this happens is not that your brain was too simple. It is that your brain was doing something far more important than remembering. It was becoming you. And that required quite literally destroying the person who came before.